So yesterday we learned the product rule, so today we're going to learn the quotient rule, or how to take the derivative when you have a function divided by another function. Right now I want you to start the warm-up. Write k of x, f prime of x, and g prime of x. We'll pause the video so you can do that. Okay, so k of x is f divided by g. So that's 3x plus 1 divided by 5x minus 4. The derivative of f by itself is 3, and the derivative of g by itself is 5. The derivative of k is not going to be 3/5. Just like we saw with the product rule yesterday, for a quotient, it's not just the individual derivatives divided. We'll get back to this d and this sentence. Right now you need to write down the quotient rule. What it says is that if you have an equation that's one function divided by another, then your derivative is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. And after you write this down, I'm going to teach you a shorter way of remembering the order that all of this goes in. So the way I remember, the way I was even taught how to remember the quotient rule, that instead of using my g's and f's, that the derivative is low d high minus high d low all over low low. And what that means is low for the denominator, d for derivative of the high, which is the numerator. So low d high, which is derivative of the numerator, minus high, the numerator, derivative of the denominator, all over the denominator squared. So you can choose whichever way you like to remember the quotient rule. We're going to do number 1. We're going to do all 6 of these examples together. So when I have the derivative of this function, I need the denominator times the derivative of the numerator, and the derivative of e to the x is e to the x, minus the numerator, high, d low. So the derivative of x squared is 2x all over the denominator squared. Now we do have to simplify this. There's an e to the x in both of my terms up here, so I can factor that out. I'm left with x squared minus 2x. And then x squared squared is x to the 4th. Okay, let's try number 2. Low d high, so the derivative of 5x squared is 10x, minus high d low all over low low, so the denominator squared. But now we have to simplify this. Distribute my 10x here and my negative 5x squared here. Oh, that's just once. Sorry. So we get 10x to the 4th plus 10x minus 15x to the 4th. And this I do want to multiply out. First, outside, inside, last. And one last step, I have an x to the 4th and an x to the 4th, so that's negative 5x to the 4th plus 10x, all divided by x to the 6th plus 2x to the 3rd plus 1. Okay, for number 3, the derivative of 1 is 0 minus high d low all over low low. Now the derivative, 0 times this is 0. So we're left with negative e to the x divided by 1 plus e to the x squared. We could have done number 3 with the chain rule instead of the quotient rule. I'm going to add that in here. So 3 again. Instead of the quotient rule, I can change my original to have a negative exponent. So now using the chain rule, times the derivative of the inside, our negative exponent moves to the denominator, and we get the same thing. Okay, so we're going to do 4, 5, and 6. Okay, so for number 4, it's low d high, so the derivative of the numerator minus high d low all over low low. Now we have to simplify this. Here we get 8x minus 2. And then this negative, I'm going to leave there for a second. So minus 8x plus 3. I need these parentheses because the negative is going to have to be distributed to each of these terms. Then on the denominator, we need to multiply out our denominator. First, outside, inside, last. And then distributing this negative. Combine my like terms. So now, simplifying my numerator one last time, these cancel. It makes 0, so we have negative 5 divided by 16x squared minus 8x plus 1. Okay, I want you to try number 5. We'll pause the video so you can do 5 and then come back and check your answers. I've got low d high minus high d low all over low low. This is 2x squared. So x squared minus 2x squared is negative x squared plus 2. And multiplying this together, here is my final answer for 5. And one last problem, number 6. This one doesn't simplify nicely. Before we can even start, we have to change our radical to an exponent. And then the derivative. one last step to simplify. This moves to the denominator. I'm going to rewrite this as a radical. And I can multiply those exponents, and that is our answer. So now your job for the remainder of class is to work on the homework. This is in your packet. Those are not the right numbers. Here we go. This is the right assignment. So on the next page in your packet on the back, those are the problems you need to finish.